everyone. This is part two. So if you are just logging into part two, you probably want to go back and watch part one of the lecture on water. So this image here I'm going to show you and we're going to talk about, okay? So these are what we call aquifers, and aquifers are water that is stored under the ground naturally. They're not man-made. They have been here forever, right? And they're these kind of caves that are full of water underneath the Earth's surface. Typically, they're lower than 6 feet. That's why we bury people at 6 feet, right? Because sometimes if we go lower than that, we'll hit what we call the water table. In some countries, the water table is super high, or the closer you get to the ocean, the water table is higher. In those cases, a lot of times in some areas, people are buried above the ground because the water table is too high. So if you ever get a chance to go to New Orleans, one important thing that you should do is tour a cemetery. I know that seems dark and strange, but they have this really cool mechanical system to deal with the fact that parts of the year the water table gets really high and the coffins are underwater, so they almost have them on a Ferris wheel type system. So really important, really cool. You can look up some YouTube videos too. But this is what we call an aquifer, and what happens is the water here percolates through, and then this naturally cleans it. So the earth, the rock, the soil, stuff underneath the ground naturally cleans the water as it gets to the aquifer. We in Philadelphia do not live in an area where we pull from aquifers. We pull from the Delaware River, so we pull from a river system. But in some areas, if you know someone who has a well or well water, they pull from an aquifer, meaning that you drill down into the ground and you make a well, and then you pump the water up to your house. Now, really important in areas like this where there's well water is, number one, you need to make sure you're not paving over the surface in these areas or the recharge zone. You want to make sure that these areas are permeable surfaces that allow the water to percolate through so they get down into the aquifer system. Paving over property is not great in these areas. For example, my sister lives in way South Jersey, and she's not really allowed to pave over parts of her property because they want the water to infiltrate through into the aquifer system. The top line of the aquifer system is what we call the water table. So this top line is what we call the water table. And if you've ever heard someone say, my well went dry, that's because the water table, if too many people are sucking water off of this aquifer system, then that water table line is going to go lower and lower if we don't get enough rain, right? And remember, it takes time for when it rains. It doesn't like overnight fill up the aquifer. It takes time for the water to work its way through this maze system into this aquifer system. So it's really, really important that not too many people are pulling off of the aquifer system, that uncontrolled activities aren't happening here, like people don't have underground storage wells that could potentially leak and then contaminate the aquifer system. So if you hear someone say, my well went dry, that means they have to actually make their well deeper. So for example, let's say this aquifer system went dry. These people who are pulling off of this well would have to dig down further into here to reach it. And that sometimes can cost almost $10,000 to dig your well deeper. Okay? So really important for you to understand that. So of course, what are the problems in these? Number one, some areas extraction exceeds recharge, meaning too many people are pulling water off and there's not enough water filling the aquifer system. Pollution, like I talked about. And if agriculture starts pulling this off, remember and Morgan in one of my classes reminded me of this. Remember you guys watched a podcast on this where people were using them for almond farming. They were using the aquifer system, and then all of the people who were pulling water off for residential use was running out of water. So really important. Okay, the next thing I want to talk about are wetlands. So wetlands are really important, and a lot of you probably have seen a wetlands before. I know this sounds crazy, but there's a couple down by John Hines Park, by the Philadelphia airport. There's a lot of wetlands down there. If you've ever gone to the Jersey Shore, you've seen wetlands. So even if you've gone to Atlantic City, you've seen wetlands, and I'm going to show you what they look like in a second. But wetlands are absolutely essential, and one really important thing for wetlands is that every mile of wetlands knocks down a hurricane by 1 category. So they help suck the energy out of the hurricane. So it's really important to have wetlands, because every mile of wetlands, remember, decreases a hurricane by 1 category. They are really, really important. They're also really important for other reasons. So number 1, this is where ecosystems are where soil is saturated all year or a significant part of the year. And the soil has little oxygen. So you know that smell, it's like a rotten egg type smell, okay? That's important because the soil there is what we call anaerobic soil, meaning without oxygen. Aerobic soil has oxygen, so it doesn't really have a smell, but anaerobic soil has no oxygen. So it has like a really sulfury smell to it. And there's a specific type of plant that grows in those areas, and they are called hydrophytes. So you're talking about your Phragmites, certain types of plants grow in these areas, okay? And this is what ecosystem the wetlands provide. They store water, flood control, improve water quality. They have tons of wildlife, super biodiverse wetlands are. But we've been filling in wetlands a lot because it's area closer to the water, right? It's areas closer to the ocean. So sometimes what we do is we put pumps in there and then they backfill it in with sand and they build houses on it, which is crazy. And you'll see on a couple slides of what happened in San Francisco, where a lot of areas that would, when it rains a lot, those areas would hold the water and allow it to percolate through. But if you build on those areas, then it doesn't allow that. So now it allows the mainland to flood a lot more. So species are adapted to saturated or anaerobic soils, rich with aquatic invertebrates and vertebrates. We have beavers, muskrats, capybaras, water buffalo, hippopotamuses, all of those, right? So here is what a wetlands look like. This is what we call a tidal marsh, which is a type of wetland. And you guys probably have seen these, right? So typically we have bridges that take you over to the Jersey Shore, which is a barrier island. And in between the mainland, which is here, and the barrier island, which is over here, are wetlands. Sometimes you see these when they've drained out and there's mud here. Okay, so these are regulated, the tidal marshes that we see are regulated by the tides, right? So when it's high tide, they come in and fill in with water. And then when the tide goes out, these are muddy areas. And sometimes you'll see a lot of people crabbing in these areas. And that's because a lot of crabs come in with the tide and then go out with the tide. So really, really important. And humans have impacted them. We've destroyed wetlands. We build a lot on wetlands, which is a major issue. It really is a major issue. Estuaries are another really important thing. And remember, estuaries are really important because they are that area between the ocean and the Bay Area. So they're the Bay Area, the estuary area, and then you go into the river system. So they're kind of like a bay, but not a bay. They're almost similar in terms of their location. One important thing to remember is that in these estuaries, really, they are huge homes to a lot of bird species. Horseshoe crabs, if you've ever heard of a horseshoe crab, lay their eggs a lot in these estuaries, and then migrating birds eat those eggs and then they go on to their next area. So they're really big feeding homes for migratory birds. They also house what we call brackish water. And this brackish water is that difference between salt water and fresh water. Remember, the oceans are salt water. Once you get into a bay, okay, the water is still salt, but it's moving to fresh water a little bit. So it's kind of in between fresh water and salt water. A mixture happens there. Okay, so really important. The next thing I want to talk about are oceans, and this is really important. So we talked about this in class, that oceans cover about 71% of the Earth's surface, and the average salinity of oceans is 3.5%. And one of the couple important things are they circulate and disperse heat around the world, and they're the most biologically diverse and abundance near land. This is super important for you to understand. These gyres, right? So there's 2 types of ocean currents. There are surface currents, and then there are what we call vertical currents, okay? So, which are deep ocean currents. So the surface currents, reach a depth of about 400 meters, and they are driven by wind, the Earth's rotation, and water temperature. Really important to remember. So remember we talked about global warming. If the oceans get warmer, then guess what? These surface currents are going to be impacted by that. Okay. And we call these surface ocean currents gyres. Okay. And I'll show you a map. There's a bunch of them. These are also where a lot of pollution gets trapped. So you want to watch this little video on the Great Pacific Garbage Patch. And that is where a lot of microplastics get stuck, all those water bottles, etc. And a lot of birds eat that material, etc. So this video is a little gross to watch, to be honest with you, but it's a great video that gives you a really impact of how what we do here on Earth affects bird species. So the next, so here are the gyres. So there's the North Pacific, the North Atlantic, South Pacific. This is where the garbage patch is. The South Atlantic gyre and the Indian Ocean one. And then we have what we call vertical currents. So we have those surface currents, which are gyres, and then we have these vertical currents. These are caused by differences in temperature and salinity. Remember, if sea level rise happens, right, or if the glaciers melt, they contain fresh water. Those melt, they change the salinity of the ocean because you're mixing fresh water with the salt water, and you're going to change the salinity. And remember, right now the ocean salinity is 3.5%. So we're going to change that, which will change the vertical ocean currents. Also, temperature affects these. These are what we call thermohaline circulation. These guys move really slow, and they're significant to global climate. The gyres are more low. These are more deal with climate close to you, right? Whereas these deal with more global climate, okay? And it's almost like a ribbon, like a treadmill that runs throughout the Earth. And the salt and the temperature pull it down. So you can see the warm surface, and then it pulls it down to the cold and then up. If you've ever noticed or been in a pool or in the ocean where it's really warm on top, and people say it has to do with people peeing, it's really warm on top because the sunlight only reaches a certain point, and then it's really cold below. So deep ocean is really cold. And this is what allows this current to circulate, okay? And it goes around the world. Of course, with humans, there are impacts. Number one, overharvesting. So you want to watch the short little video on overfishing. That is a tragedy of the commons. It's a current day tragedy of the commons. And you can see here pollution, of course. We've exploited our oceans. So how can we conserve water? Well, we could do crop irrigation. So meaning we could figure out more efficient ways to irrigate, maybe water at different times of the day, stop spraying water above, like, when we put sprinklers that spray water into the air, instead of having like drip lines that go along the ground and allow it just to drip in. A lot of that is evaporated. So if you are putting a sprinkler on and it's 100 degrees out, a lot of that water is just going to go right into the atmosphere rather than getting into the ground. We could, of course, reduce water use. We can use gray water systems. We can also desalinate. But as we discussed in class, desalination is really expensive. There's two ways to do it. There's either reverse osmosis, or there is where we boil off the water, and that requires a lot of heat and energy. And again, this contributes to climate change. This is what a desalination plant looks like. You can see here how the water's coming in off the ocean, and then it's put through this enormous plant. This is like a huge task and adventure to go on in terms of desalination. And then there's different, you don't need to know these water rights. This talks to you a little bit about sewage treatment. So you want to go through this. We kind of talked about this in class with what the combined sewage treatment, right? We talked about that with the Audubon Society, and I included that video. So you want to watch that video as well. But there's a little bit more information here. Okay, so that ends my second lecture, and I hope this brings you up to speed on water. I look forward to seeing you back in class again on November 27th.